Hello again, class. It's Mr. M, here to talk to you about today's main part of the lesson, and that's special right triangles. So here's a copy of the slip that you hopefully picked up after your assessment and stapled to page 299. So let's take a look at it. So if you haven't already, go ahead and turn back to page 299 so you're looking at this slip. Alright, what is this good for exactly? As the slip tells you, and I've cut it off here on the digital version, but the slip tells you that these two shapes are like the master copies, or the originals, right? The original signed documents that a bunch of copies of these shapes come from. These two shapes appear very frequently in various areas of mathematics, as we'll see, some aspects of. And in order to keep from having to do the same math over and over and over again, we can just refer back to these relationships and have those relationships do all the hard math for us. So one of the important parts to recognize here is that you have to memorize these. Alright, I normally don't like you memorizing things. I like you to be able to understand concepts, but your lives will be a lot easier if you do memorize them. And one of the reasons for that is, even though these are a small concept in the grand scheme of what we cover in geometry, they end up being very important in trigonometry as well as Algebra 2 and other future math classes. So this is sort of your foundation for a lot of what you'll see in the future. Okay? And here we have our two special shapes. The 45-45-90 triangle, named for obvious reasons, just look at its angles. And the 30-60-90 triangle, likewise for its angles. Well, looking at the 45 and 45, two of the angles are the same, right? Which would therefore lead one to conclude that two of the sides are the same. And you'd be right. They're both A and A. So it doesn't matter what A is. A might be a different number, as we'll see in various examples. The fact is, whatever number that happens to be, then the hypotenuse is going to be that same number times the square root of 2. It could be 5 and 5 as the shorter legs. Then the hypotenuse is 5 square root of 2. It could be 9 and 9 as the shorter legs. Then the hypotenuse is 9 square root of 2. And so on and so on. So that's the 45-45-90 triangle. The 30-60-90 is a little more complicated. You have two angles, one smaller than the other and one bigger than the other. So notice that the smallest side is across or opposite the smallest angle, right? A is across or opposite from 30. The biggest side, the longest side, which is 2A, is across from the biggest angle. That's 2A. And the medium-sized side is across from the medium-sized angle. So that hopefully makes a bit of physical sense to you. The relationship here is that the longest side is twice as long as the shortest side. Do you see that? It's 2A compared to A. Again, what A is depends on the particular problem. The fact is the ratio will be built from the special right triangle. And likewise, the medium side is not, it's not 2A, that'd be too big, and it's not just 1A, it's too small, so it's somewhere in between 1 and 2, namely it's the square root of 3. So once again, this ratio will help you deal with some problems. So let's look at some of these problems, and we're going to look at the worksheet in just a minute, but before that I want you to just follow along with this example. So you don't have to write this next example down, you can just follow along with the video, alright? So, forgot to give you a number here, so let's call this 7. Okay, let's look at this shape. Well, there's two things that are missing. That's bad news. Let me actually give these variables. It's hard to deal with the question marks. Let's call it A is confusing, X and Y. Well, you might think, alright, easy problem, Pythagorean theorem, A squared plus B squared equals C squared, I got this. Well, maybe. But here's the problem. You have two variables. You have only one equation. You're not going to find x or y doing it this way, at least not one individual solution. So that's not going to work. Pythagorean theorem, not enough information for that. Well, the good thing is we're not out of luck. We can still solve this. Because this is just a specific case of the general case which you have on your slip. Right? So the general case looks something like this. It has A, and it has A on the square root of 2. And again, that's because you have a 45 here, you have a 90 here, and even though this is not given, you know this has to be 45 degrees. And think about why you know that. It's because all triangles have a 180, but anyway. Okay, so we have this picture, right, in the back of our head, hopefully memorized in a couple of days. So what you want to recognize is that 7, right, the 7 that we're given is in the same role as A, right? 7 and A match. So you know that X is going to have to be the same, because it's also A. And Y, which is the bottom side here, is simply whatever A is on the square root of 2. A is 7, therefore it's 7 root 2. Done. No Pythagorean theorem, not even any complicated math. Just matching the physical picture with the original model. Right? The slip represents the model. All the other ones come from that original master copy. Okay? Let's look at a harder one, and this is the 30, 60, 90. Again, just follow along. You'll have a chance to do some examples in just a minute. Okay, well, this is harder. Let me replace these again with X and Y. X and Y. Okay, well, a lot of stuff going on here. If I'm anything like you, I may have to look at my slip here and make sure I know what my 30, 60, 90 relationship is. So on your slip you have something that looks like this, and I couldn't fill it all in one slide here, so I had to kind of improvise. So this was 60, this is 30, and on your paper it says 2A, A, and it says A on the square root of 3. Okay, well, I don't see a square root anywhere here, and there's a lot of other stuff that's confusing me, so let's take a look at this. I'm given this 5, so I need to start there. So what I got to figure out is which one of these three things, right, 2a, a, and root 3a, which one of them is 5? Well, notice, the 5 is directly across from, right, it's directly across from 60. So they're related to each other, 5 and 60. Well, go to 60 in your model, and you'll notice root 3 times a is directly across from 5. So that means, in proportion, right, you're going to have 5 from your specific triangle and a root 3 in your model, right, from your master copy. So they're going to be related to each other, right? And we got to figure out what x is equal to. Okay? Well, for example, for x. Well, x is across from this angle over here, which is 30 degrees. And again, we know that because all the triangles make 180. So x is going to connect up with with 30, right? Well, in the model, a connects up with 30. Okay? So to complete our proportion here, we have x, and it matches with a. 5 is to a root 3 in the model, as x is to a in the model. And there's your proportion. Cross multiply, and you have 5a is equal to, well, this may be a little complicated, but notice you have x, you have a, you have the square root of 3. None of those are like each other. They're all different. So just x times a times the square root of 3. Well, you have something in common on both sides, namely a, so you can just get rid of that. That's easy, right? Just divide both sides by a. And goodbye a. Nice knowing you. Now you just have, let me continue the work down here, 5 equals, the a's are gone, so just x root 3. Well, we're looking for x, right? Divide both sides by root 3. It's just a number. You can divide by a number. It's easy. And there you go. X is equal to 5 root 3. Sorry, 5 over root 3, I meant to say. 5 over root 3. Well, that's this part right here in the model. Well, notice the longest side, which is y in our specific problem, is twice as long as that, right? So instead of 5 over root 3, it's going to be 10 over root 3. And there you go. Done. Not easy, but, you know, you couldn't use the Pythagorean theorem, so what else are you going to do, right? Okay, let's do some more concrete examples that you can actually follow along with. And this will help you with your homework. In fact, it is 2 parts of your homework. Lucky you, less homework. Take a look at numbers 1 and 2 on the worksheet. And I'm going to walk you through these, and then you can do the rest once you have your training, so to speak. Okay, so I've got the diagrams here. I don't have to redraw them, so that's good. Problem number 1. You got 10, right? 10 represents this part of the 45, 45, 90 triangle. So that means 10 is going to, in essence, be the same proportion as a on the square root of 2. Right? They're proportional. Okay? Well, we're looking for example, x here. X is going to match with a on this triangle. So 10 is to the root as x is to a. Cross multiply. 10a is equal to x times a times the square root of 2. You can cancel a out from both sides just like the last problem. And you have 10 equals x times the square root of 2. Once again, square root of 2 is just a number. Divide by it since that's multiplication. Divide both sides. And voila. 10 root 2, whoops, is x. 10 root, whoop, that's y. 10 root 2, there's x. Well, that's a, or x. That's the exact same thing, isn't it? Those are about the same. So, even less work. 10 over root 2. Fair enough. Number 2. Now, number 2 may look more complicated. We just saw an ugly 30, 60, 90 problem, but number 2 actually is quite nice. Notice that 2 root 3, which is across from 60, matches with a root 3 on the model, right? From the master copy. Well, those are very close to each other, aren't they? A root 3, 2 root 3. Which means that obviously a is equal to 2. A root 3, 2 root 3. The only difference there is a and 2 have been substituted. So now that we know a is 2, look back at the model. The short side is just plain old a. So the short side is 2. The long side is 2a. And 2 2's, children, makes 4. Done. Next problem. That's the power of special right triangles. You can notice patterns and repetition, therefore you can approach problems that are more challenging and difficult to do without more information, and that's why they're called special. They are special. Alright, hope this helps.